The principles of OOP. The first principle, abstraction. To simply put in action, that tutorial keeps telling you to collect points, as many as possible. And that's it. There's nothing more than collecting points. All you have to do is just run over or run towards where the points are, and you collect them. Abstraction is hiding elements of an object from other programs that we don't have to worry about. What goes in and what goes out. You don't need to worry about anything about collecting points. Second is polymorphism, the use of a word that comes in many different meanings, yet the expectation is high. In this scenario, I am trying to enter someone's house, which might be the most impolite way to do that without permission. How do we use the word enter? We can't enter the door because we presume it's locked, so we can try to parkour up way up there to somebody's house, somebody's rooftop, or the chimney, or we can attempt to if there's an entrance to the back house, then we can enter somebody's house. Encapsulation is the third principle that uses all required elements for an object and combine as a whole. Even a large code amount is enough to put together. So as you can see right here, I have two actors, the dragon and the griffin. This dragon here, this dragon can be is a this dragon here. What makes a dragon as a whole is that one of the following elements that the dragon needs is flying, walking, and sometimes the dragon will need the elements to bite. This griffin here is also similar to the dragon. The griffin needs the elements of such as walking, flying, and also attacking. The last principle is inheritance, the ability that based on other objects. Given the computer visual description of what they can do, allow users to find general concepts and create simple objects. So as you can see right here, both actors I have both actors are belong to the similar class, which is a creature class. However, a dragon could consider a reptile class, while Griffin would belong to a creature class, or a Griffin could belong to a bird class. Maybe it could be a mammal class, or it could be just or the Griffin could just be it just could belong to the general creature class. Loading to the next level is similar to the functionalities of the start and game over screens. As you can see here, this is how the functionalities of the loading to the next level work. So as I'm about to test it out, as I'm trying to reach to where the this location that will initiate or load the next level. There you go. There are two variables, speed and chasing player. Both have different types. Speed is the float variable and chasing player is the boolean variable. In this scenario, I have three types of enemies that will demonstrate the variables, movement, frame rate, and collision. As you can see right here, these are the blueprints following the I had to look back to the lecture video in order to make sure what I'm doing or not to forget. So each of these enemies are the normal enemy, which is the green one, the flying enemy, which is the one in the air, and the ghost enemy, which is the purple one. As you see here, this normal enemy is currently chasing the player character because it has the chasing player set to true. Boolean is a value that does one thing if it's true, and a different thing if it's set to false. So if I were to set true to both of these enemies and leave the ghost one false, these two enemies will chase the player character, but not the ghost enemy, because the ghost enemy chasing player value is set to false, meaning they will not chase the player. The float variable is a variable that stores decimals or individual number points that can float to the list of digits. So if we want the enemies coming at us, we want a certain function or a node that will make the starting point and the ending point. And that start point will be the enemy, and the player is the enemy's ending point. Without the ending point, the enemy will not know where to go to the end point. So if we want to make the enemy chasing the player, then we want to make the enemy to have its own ending point. Yeah, we want to make the enemy to have its own aiming point and the ending point. So that means that the player character must be the enemy's ending point, which, of course, um, following the lecture video provided again, uh, again, by changing the value of by changing the value um, in the following functions inputted in the blueprints will change units per second on the Unreal Engine, not per second. So if I were to, so as you can see right here, so if I were to change the speed value for the flying enemy, the flying enemy will move slower. If I set to a higher value, the flying enemy will move a little bit quick though, but that depends on the units per second, not on frames. Because this flying enemy right here is I would say like I'm pretty sure I said to 500 units per second. So if it's like 500 units per second, then that would make it um let's say like 5 seconds on Unreal Engine, not per, not like per, not per, not 5 frames for the flying enemy. So if I would set the value to quite low, I'm pretty sure I might mention it, quite low, then the enemy will move a bit slower. As you can see, I'm trying to change the make various changes to the ghosts. If I were to make changes on the collision, the enemies will get hit by a rock or they'll pass through the rock. Um, so by changing the collision, setting to trigger will allow actors to pass through to pass through other actors, which if I would set the ghost enemy to trigger, then that ghost will pass through a rock. If I were to set the ghost enemy to block all, then that ghost enemy will not go through the rock. Instead, they'll get hit by the rock. Signal-tone pattern grading values game programmers coming from their interactions with computers. The reason is that Singleton treats object where there will be only one. It holds information about the game and provide easier access from anywhere in the codes, meaning that game programs can write codes to a Singleton object. It makes the development process easier when we think back to the principles of OOP or OOP. The objects sorry the principles of OOP and the objects needed to make this game. Using game instance on the player's life can be a great example because it can hold the data of lives and persist between levels. Let's say if a player dies, and their lives amount went to 4 or 3, it will keep that amount whenever the game loads a new level. There are times where programs need to decide the easy way or the way of extra time and effort. It may be possible to avoid technical debt by making the codes modular, meaning they don't have to rewrite codes. They can only worry about that single code, because it helps them avoid technical debt in case of future changes. So um, let's say that you need to decide the easy way if the deadlines are nearby. If that's if the deadlines are near, you need to then the progress will decide the easy way. Every game console in development mainly requires feedback. Without the eh, without the acknowledgement for players, they would know or they may not realize the game is performing something majorly important. It can be anything from mechanics aspect to the aesthetic touch in the game stories. Using the UMG or Unreal Motion graphics will allow me to create UIs or user interfaces in game projects. Creating the widgets provide definitions such as the UI elements displayed on the screen right now, um, such as the wizard names popped above his head and his dialogue speech are the examples of the widgets providing definitions. Applying or inputting the changes and functionalities into the widget's blueprint will carry over the effect once the game project is currently on play. Throughout this video, a player character has gone through quite a couple explosions to show the elements of the set and variables. The player character is the actor, meaning if I were to quote code to spawn an actor, the player will respawn. A player that runs out of lives considers destroying the actor.